from South Asian University, Department of Economics, South Asian University, New Delhi. Sir, I have a lot of exposure of doing good quality research and work on productivity and efficiency. And we are lucky that Sir has agreed on our request, and this is also a blessing for us. Sir is present at here, and you people are also lucky that you are able to learn from such a renowned person and such nice teacher. And I make one thing clear: you are here since last 6 months, and many participants are from other universities also. Today you will be able to make a gap between a teaching person and non-teaching persons. And after that I will ask to you whether you previously you have met any teacher or not to meet any teacher. So we are lucky, sir. Thank you, sir.
Thank you very much for those kind words. So I will try to reflect on the concept and determinants of productivity in the first part of my presentation. Then in the second part of my presentation, I will come to the actual estimation methodology. So there are alternative methods of estimating productivity, so I will try to make you aware of some of those techniques. Of course, not all the techniques will be possible, but at least some of them. And then in the third session, I will take you to the soiling your hands through certain exercises. So I will show you in the Excel sheet that how you extract the data and how you actually operationalize those concepts to estimate the productivity. So in the first session, we try to talk about the concept and determinants of productivity. What exactly we mean by productivity? And why are we interested in this concept of productivity? How do I move the PPTs? Thank you. So you can actually make a distinction between factor productivity and total factor productivity. So factor productivity is a very simple thing. So you take value added and value added divided by, let us say, labor. Okay. So you will get value added per labor. So that is what is called as your labor productivity. But labor productivity can be misleading. Why? I tell you. Suppose you are producing 100 units of value added of, let's say, iron and steel. Now you can have alternative techniques of production. So you can engage 2 units of capital, 50 units of labor. Okay. So what is labor productivity? 100 divided by 50. That is your labor productivity. Now suppose someone suggests that no, I will not use labor intensive method. I will use capital intensive method of production, where I will be engaging 10 units of capital and 20 units of labor. Okay. So 100 divided by 20. Labor productivity is high. 5. So can you really compare between them? No, not always. Because in a labor surplus economy like India, labor price is much lower, much lower than capital price. So if you are engaging 10 units of capital, then that means the cost can be enormously large. Whereas in a capital rich country, particularly the European nations or United States, their labor price is very high. So they do not want to engage human labor. So they would like to engage capital. So this concept of labor productivity, or what we call as factor productivity, can be misleading. We cannot sort of conclude anything very assertively based on this concept of labor productivity. That is the reason why we are interested to measure total factor productivity. So total factor productivity would try to sort of net out the entire expenditure that you are incurring. The expenditure on capital, the expenditure on labor, material, energy, etc. And then to see what is the gain. So on the one hand you have the output series, on the other hand you have the input series. So you net out the input from the output. Of course it's not so simplistic, I will show you, but concept wise it is basically you net out the growth of the inputs from the growth of output, and whatever the residual is left is called as your total factor productivity growth. Perhaps, so in conceptually we say total factor productivity growth is equal to technological progress plus change in technical efficiency. You don't have a board here, no? It would have been very interesting if I could draw certain things. Anyway, I'll try to draw in the air so you will be able to follow. See, technological progress would mean, suppose in the horizontal axis you are taking inputs, and in the vertical axis you are trying to take the output. So you will be able to see an inverted U-shaped relationship. What that is called as your production frontier. For a given level of input, what is the maximum attainable level of output? Okay. So at every point of input, you are able to see this kind of a curve. But from reality point of view, not necessarily we will be able to reach that optimal point, because there are many constraints which will not allow us to realize the maximum attainable level of output. So we will be below that frontier. Okay. So then when you are below that frontier, you can measure to what extent you are closer to the frontier and to what extent you are below the frontier. So when you are closer to the frontier, that is measured as your efficiency, and the distance below the frontier is called inefficiency. So suppose you can produce 100 units of output, you can, but you are not actually be able to produce 100 units of output. You are producing 80 units. So 80 divided by 100 is your efficiency. 20 divided by 100 is your inefficiency, percentage wise. Okay. So that is what is called as your technical efficiency. Now imagine that curve which is given shifts upwards. Shifts upwards means for given level of input, now you are able to experience much higher levels of output. Okay. So that is what is called as your technological progress. So technological progress would mean that for a given level of input or for given levels of inputs, you will be able to realize higher and higher levels of output. So now when the new technology comes, whether your efficiency will remain as 80% or will increase or will decrease, that is the question. Suppose I am using this laptop. I have certain packages, etc. Suppose all of a sudden, a very new technology is given to me. So new technology is supposed to improve my efficiency to a much larger extent. But in reality, I may not be able to do so. Suppose I do not know how to access, how to utilize Pentium 11. Okay, fine, Pentium 4, 5, fine. But Pentium 11 comes. I do not know how to utilize the very advanced level of technology. So I will be struggling to utilize that new technology. So what it means that when the level of technology improves, technological progress takes place. This was the frontier, now you have a higher frontier. Technological progress has taken place, but that does not necessarily mean that I will be able to realize the new potential of the new technology. It is quite possible that my efficiency may come down or efficiency may increase. So what you are able to see that this technological progress can be a positive, let us say 5%, it can be positive. But change in technical efficiency can be negative. Change in technical efficiency, old technology, I was 80% efficient. With new technology, maybe I am 70% efficient. So that means efficiency has come down from 80% to 70%. So this quantity can be positive, but this quantity can be negative. And if the negative quantity is greater than the positive quantity, total factor productivity growth can be negative also.
Yes.
You understand? So, not necessarily total factor productivity growth is always going to be positive. It can be zero, it can be extremely sluggish, it can be negative also. And that is what the problem is. So we are saying economic growth must shoot up. We must work on strategies to maximize our economic growth. But economic growth maximization does not solve the problem of the developing countries. Because you may be experiencing technological progress, but your technical efficiency may be coming down. You measure the technical efficiency for each of the Indian industries. You would find total factor productivity growth is very, very low. 1%, negative 0.01%, something of that kind. So, which means that economic growth can be 7%, 8%, 9%. That means you are utilizing a lot of resources and you are experiencing higher growth. That means for the future, you are not conserving your resources. So if you utilize more and more resources and you experience very high levels of growth, there is no credit at all. Credit lies in the fact that when you are able to generate more and more growth with lesser and lesser utilization of resources. Or to put it differently, with the same level of resources, you should be getting more and more output. How is that possible? That is possible only through your innovative methods, innovations. So so you are able to make a distinction between factor productivity and total factor productivity, and then total factor productivity, as you can see, is basically a combination of two important constituents. So technological progress and change in technical efficiency. Most of the governments, most of the countries, most of the entrepreneurs are directed to raise the technological progress, but they do not pay much attention to raising the technical efficiency. That is the reason why sometimes we find technological progress is enormously large, but technical efficiency is not improving. Rather, it is deteriorating. Some time back, there were some newspaper clippings that were in very advanced medical institutions like AIIMS, etc. They have acquired very new technology from other developed countries. But the doctors and other scientists and the researchers, they did not know how to utilize those technology. So those machines were lying locked inside the chambers. So acquiring technology does not necessarily mean that we will be able to improve our performance. So that is why total factor productivity growth can be negative. So now we will try to sort of talk about this concept that in what way our total factor productivity growth can be raised. So non-resource driven growth is the key to sustainable development in the long run. That is the key point. With high growth, that is no credit at all. You should be utilizing resources to the minimum possible extent, but your growth should be maximized. Then only the difference between output growth and the resource utilization growth will be large. And if that difference is large, it would mean that your total factor productivity growth is also high. So growth in output, which is more than proportionate increase in inputs, is attributed to total factor productivity growth after controlling for returns to scale. So there is a concept called returns to scale. Returns to scale, you must have learned it at the undergraduate level. So when a firm is starting its business, so you will find you are utilizing certain factors in indivisible terms. You cannot buy capital like 5 units of capital, 10 units of capital. No, it's not possible. You acquire a huge bunch of capital, 100 units of capital. So that means initially, if you are producing less, the scale of economies can be enhanced with the same level of capital. If you raise your volume of production, you don't have to raise your capital. Already you have acquired. You have already lot of stock. So that is called as your increasing returns to scale. Similarly, you will have constant returns to scale. Beyond a point, you will find that output will be increasing in proportion to the inputs. Then the phase will come when decreasing returns to scale will start. That means the returns to the utilization of resources would be less and less. So we are not talking about that concept. So total factor productivity growth does not refer to this particular concept. That is a stylized fact. That is a obvious thing. That the moment you start a business, there would be increasing returns, constant returns, decreasing returns. So we are not referring to that. After controlling for returns to scale, what we are able to see that the difference between output growth and the input. So that means we try to presume that there is constant returns to scale. Output is increasing, input is increasing. You are not taking advantage of the stage at which you are located. You may be in the initial stage, you may be at the mature stage, you may be having a very, very old farm. That is not a concern. Concern is what is the output growth, what is the input growth. And that difference should be as high as possible. That is what is called as your TFPG. Now you know in the literature what are the determinants of growth has been a very important proposition. And it started from the 1960s, that in what manner we can augment our overall growth. So Solow, who got the Nobel Prize, he was basically the first one to say it is technological progress which can augment your growth and also total factor productivity growth. He was the first one to harp on technological progress. And but then we would be able to see that there are many other factors which are also determining your total factor productivity growth. So one class of literature emerged that is called as your endogenous growth theory. Endogenous growth theory would say that growth is the dependent variable and you have a number of factors which can contribute to economic growth. So one class of literature suggested that good governance is very important for growth to be maximized. Similarly, another class of literature said human capital formation is very important. Another class of literature suggested that trade relationship is very important to improve your growth. So role of government, role of state, infrastructure building. So likewise, a large number of factors were identified as the determinants of economic growth. And that is what is called as your endogenous growth models. Romer is called as the father of your new endogenous growth theory. So he basically referred to a wide range of factors, and towards the end he also includes the ICT. That the role of ICT is also very, very important, that it can also contribute to higher levels of growth. Given capital, labor, role of state, etc., all other factors, your ICT augmentation can also contribute to high levels of growth. And then another class of literature which emerged much later, that is your import of technology and FDI. They suggested that most of the time the developing countries do not have enough resources. They have to struggle with poverty reduction, etc., etc. So they do not have enough resources to undertake innovation. Then where will they get the innovative resources to pursue technological progress, etc.? So there the suggestion was that, okay, you try to procure the technology from the developed countries. So there is an organization called UNIDO, United Nations Industrial Development, Industrial Development Organization. So UNIDO, its headquarters is based in Vienna. So UNIDO tries to suggest that every country must industrialize. So their motto is, slogan is industrialize or perish. So every country, if has to progress, has to modernize, then must try to pursue industrialization. So from that point of view, what it was suggested that technological progress must be encouraged. But the developing countries are not able to pursue technological progress. What will then happen? They say that if the developed countries have already innovated a technology, then it can be imported by the developing countries. So developing countries are resource scarce, so they do not have to waste their resources in rediscovering the wheel. So the proposition is, if the wheel has already been discovered in some part of the world, it need not be rediscovered by the developing countries again. So it can be imported by the developing countries. So for import of technology, can't we have some control over the activities which are going outside? Can we not convey any message to उनको कुछ बता नहीं सकते हैं कि ये बहुत ज़्यादा हो रहा है? So the question is, how would you import those technologies? Because the moment you import that technology, cost is involved. So foreign exchange, you have to have enough foreign exchange. Now your exchange rate is undergoing a devaluation. That means for the same good, you will have to pay more and more foreign exchange. So how would you get that? So from that point of view, what they suggested that you will have to demolish all trade barriers, etc. So your trade barriers will be removed so that you will be able to undertake trade strategies which will augment your exports to a significant extent. So when your exports will rise, obviously your foreign exchange earning will increase. So from those increased foreign exchange, then you will be able to import those or buy those new technologies. So that is what the UNIDO had suggested. And then UNIDO also suggested that you should encourage FDI, foreign direct investment, to your economies. All the developing countries must try very hard to get the FDI from other countries. Because the idea is when FDI comes, it doesn't mean only some money will flow into your economy. Along with the money, the new technology will also come.
Yes.
The innovative methods would also come. So the technical requisites would also come. Collaborations will take place. So your human beings would be able to learn more from the foreign nationals. So that was the kind of suggestion which was being made. So FDI and import of technology and FDI also result in technological advancement, contributing to total factor productivity growth. When Kuznets got the Nobel Prize in 1966, so he was basically trying to argue that the developed countries must keep on innovating, one after another. They should not be sitting down quietly. One after another, new technology and new innovation must take place. And the developing countries would be chasing them. So there would be a kind of race. The developed countries are running ahead and the developing countries are trying to catch up. So that is the key to progress. The moment the developed countries will sit down quietly, then the developing countries will catch up, and once they catch up, the game is over. So therefore, to continue this process, it is very important that productivity growth has to take place. And productivity growth will come only when you have this race is happening in a continuous manner. When the developed countries are able to pursue technological progress in a continuous manner, translating into shifts in higher levels of productivity, then only the world will experience a continuous trend of rising productivity. But right now, we are able to see at the global level, TFPG has witnessed a deceleration in the recent past. Total factor productivity growth at the global level has been declining. So that becomes a major question, that why it is not improving at the global level. The productivity decline is indicative of poor performance of both from the point of view of the developed as well as developing countries. The developed countries are not able to innovate more and more. They feel that the ICT is a crucial component for innovation, and ICT has already reached a boom. Further improvement in ICT is not taking place. I mean, whatever improvement is taking place is only marginal, but not really a ICT boom in that sense. So unless a new ICT boom takes place, it is not really possible to have new technological advancement. So from that point of view, their idea is that the developed countries, thank you so much, they are able to see that the developed countries are not able to experience further increasing in innovation and technological progress. So once it has come to a standstill, then the developing countries are also not able to experience much better technological progress. But investment growth has slowed down. So there we are also able to see that investment is an important determinant of total factor productivity growth. And the investable resources are declining. In many countries, the government is in dire need of resources. So it is taxing some of the enterprises at a very rapid rate. So like in the US, for example, the tax rate is very high. Even a student pays tax rate. Because you are receiving fellowship, so you pay a huge amount of tax to the government. So from that point of view, what happens? The investable resources, the quantum of investable resources is declining. And new innovation requires more and more resources. The innovation which you had undertaken in 20 years back, compared to that, the new innovation would require more resources. And that additional resources, many countries are not able to generate. So therefore, investment growth has slowed down in both developed and developing countries, with implications on innovations skills and infrastructure. Because then the revenue is declining, so out of that reduced revenue, obviously, infrastructure, etc. are not being created. The technological progress among the leaders has decelerated, particularly the countries which were supposed to lead the whole economy, supposed to lead the entire world, they have now failed. Failed in the sense their innovation process has come down, and therefore technological advancement in those countries has also been reduced significantly. Even when factor input contributions remain relatively strong, TFPG declines upward in the emerging market economies. So once the developed countries are out of the race, then we would be expecting from the emerging economies, because they are the ones which should be able to contribute to total factor productivity growth. But the emerging economies, except China, I don't think they are able to do good. And for China, we do not know what is the actual truth, because their data, can be cooked up. So we don't know whether that data is reliable or not. But if you believe that Chinese data, you will find that China's total factor productivity growth is much higher than India or any other emerging economies. So on the one hand, we are able to see that the developed countries are not able to take the lead role which they were expected to take. On the other hand, the emerging economies have also failed significantly, and hence they are not able to contribute to the world total factor productivity growth. And the other point relates to the contribution of ICT has reached a saturation point. So already whatever the ICT sector could contribute in terms of total factor productivity growth has been done. Now in the last 10 years, whatever advancement is taking place in the ICT sector is only marginal. It's not really a significant breakthrough compared to 60s or 70s or 80s. In 90s we experienced a major breakthrough. But after that it is only some marginal additions. So therefore your total factor productivity growth is not really picking up significantly. Okay. Though the labor share is on the decline, the share of intangible capital is on the rise. Another reason why total factor productivity growth is not increasing is because of intangible capital, which is very, very expensive. Like, what is a value added? Value added is a function of capital and labor. Okay. Or output is a function of capital, labor, material, energy. Now, capital is not homogeneous. Capital can have many components. So, to simplify it, we can say capital can be tangible capital, the physical capital, which would include your land, machine, everything, and the intangible capital. The intangible capital is the human brain. So, the human brain which can actually initiate the innovation. So, what we are able to see that the physical capital price is increasing, true, but not so much in comparison to the intangible capital price. Intangible capital price is enormously large. Even after creating these European unions, you would be surprised to see that there is tremendous competition among each of the countries. Who is going to innovate a particular technology? And suppose Germany has done it, Germany is not going to share it with other French or Spanish companies free of cost. No? A huge cost is involved. So you are able to see that the cost of intangible capital is extremely high, and it is increasing steadily over time. And that is the reason why your total factor productivity growth has been very, very sluggish. So if you yourself cannot innovate, then you will have to buy it, and if you buy, then obviously all your foreign exchange or your resources are gone. Japan, for example, you know that they have land scarcity, such a small country, and almost 2/3 is hilly areas and water, etc. So only 1/3 plain land they have. So they are not in a position to even cultivate their food items. So even the ordinary food items would be imported. Much of the vegetable, etc., they are imported from the rest of the countries. So where will they get the resources from? So what they do, that their motto is for every company, for a very small company also, motto is work on productivity. Work on productivity means you try to innovate. You try to innovate a technology such that you will be able to sell it to the world at an enormous the high price, and then you will be able to earn the money, and with that money you will then import the food items, etc. So their motto is modernization without westernization. So don't try to follow the Western world. We would follow the modernization path in our country. So that is how the your intangible capital price is going up, and that is the reason why these countries are not able to experience very rapid total factor productivity growth. So on the other hand, a number of reasons are cited to suggest that new technology can still create new employment opportunities. Vivarelli had a paper, Marco Vivarelli, an Italian economist. So he is very hopeful. He is very optimistic. He tries to argue that yes, I agree that intangible capital price is very high and total factor productivity growth scenario is very bad in the world situation, but there is still hope in the sense the fourth industrial revolution can create new strategies, can give us new scope for development. And he suggests that if everyone would be engaged in innovation, trying to sort of innovate certain new technology, etc., then the new technology will come to the real world and the price of the new technology will slowly come down. And once the price of the new technology comes down, then it will become affordable for every company, for a small company as well as for a large company. And then he says, he argues that product diversification can take place. We have been manufacturing only a certain range of products. Then each company can pursue product diversification. Instead of producing only X for several years, it can produce X and Y. So with the same resources, when you are diversifying your products, then naturally cost will come down. Like in the Thane-Belapur region in Maharashtra, you had many companies where they used to throw away some of the raw materials because they thought it is a product of the production process, byproducts of the production process. Slowly they learned how these byproducts can be processed. So earlier, suppose they were manufacturing only X, now with those byproducts, they are able to manufacture Y as well. So X and Y both are being manufactured. So the cost of production has come down. In other words, total factor productivity growth is rising. So from that point of view, Vivarelli is very, very hopeful. He says that fourth industrial revolution should not create a terror among us. We should be able to recognize the positive aspects of the fourth industrial revolution. I mean, AI is there, which can be applied in every field, but then it also requires the help of the human beings. And in what way the complementarities can be developed is the key question. And he is very hopeful that such complementarities can be created. He also mentions about a very interesting point. He says, what do you mean by economic development? Economic development doesn't mean that certain indicators will be satisfied. Fertility rate will come down, mortality rate will come down, better educational attainment, better health quality. No, it's not just that. Economic development also means that how many new products you are able to bring to the economy. So when you are pursuing the production of new products, automatically it would mean that innovation will take place. And that innovation is going to sort of contribute to the total factor productivity growth. So this paper by Marco Vivarelli is very interesting. Of course, he is very modest. Towards the end of his paper, he says, well, this is only a theoretical conjecture. Now, we need to see empirically whether we will be able to actually realize these benefits or not. Labor-saving effects of technology can be offset through these are the reasons which he has talked about. New products created using new technology, decreasing wages resulting from price adjustment mechanisms. He says that many companies are complaining that labor cost is very high. But actually, you have replaced labor by machines. So in that sense, labor cost is not always increasing. Yes, intangible capital, that means the labor which is engaged, which is highly skilled, the price is increasing at a fast pace. But he is very hopeful. He says that when technology will be domestically innovated, then the cost is going to decline and that will contribute to total factor productivity growth in a significant manner. So when we are saying that we want to actually endogenize growth means we want to take economic growth as a dependent variable and we want to identify the determinants of economic growth. It is same thing as saying that we must try to identify the determinants of total factor productivity growth. Because I argued right in the beginning that economic growth cannot be the right indicator. Our media is flashing that economic growth maximization, but that's not the right criteria. The right criteria is the total factor productivity growth. So what are the determinants of total factor productivity growth should be the key question. So that is why we say endogenizing total factor productivity growth is same as endogenizing growth theory. Okay. So I mean, I'm not saying growth is same as total factor productivity growth. What I am saying, the determinants of economic growth can also be taken as the determinants of total factor productivity growth, the causes, the contributors. So when you look at the endogenous growth theory literature, Arrow, again who got a Nobel Prize, so his work again related to the modeling technical change. That what can motivate companies to come up with new technological progress, with new technological change. In what way you would measure technological change? So all those questions were taken up. I mean, in what way knowledge can actually be translated into workable strategies? I mean, there should be a coordination between what we are learning at the knowledge hubs and there should be a lab where we are actually able to translate into operational part. Otherwise, that knowledge hub will remain restricted and it will not result in tangible outcomes. So Arrow's point was basically that we have to constantly work on technical change and how to convert that technological change into operational strategies. And following Arrow's model, Solow also talked about technological progress. So the other knowledge-based endogenous growth models, for example, the imitation model is derived from the work of Barrow and Salai-Martin. So the first paper which appeared in the World Bank Journal by Barrow and Grossman, that was sometime in 1976. World Bank Economic Review, the paper appeared, that what are the major determinants of economic growth, total factor productivity growth, etc. And when you were saying that technological change is the key determinant, what will then motivate for you to pursue technological progress? And there many others contributed. Salai-Martin, who was a PhD scholar of Barrow and subsequently he co-authored with Barrow and came up with many suggestions. And then you have Romers, another influential knowledge-based endogenous growth theory. So their whole importance lies in the fact that the knowledge level will have to improve. The knowledge level, once it is improved, then you can think of creating labs where the knowledge, enhanced knowledge, will be translated into workable or operationalized strategies. Here, Senna's study particularly, they again emphasized on research and development. So that means each company must have a research and development wing where innovative activities would be pursued. There is a very interesting study by Center of Development Studies from Trivandrum. So one of the faculty members had conducted that how authentic the research and development expenditure is. And he showed that much of our figures of the companies shown under research and development is all fabricated. Your staff will visit foreign countries, so that entire expenditure, travel expenditure, will be shown as research and development expenditure. You invite people from abroad, they would be residing in the hotels, that entire expenditure will be shown as research and development expenditure. So there is a huge, and why they do show such high figures under research and development head? Because the government will give you a lot of tax benefits. You might have seen that movie Guru by Abhishek Bachchan and Aishwarya Rai. So in those days, exports, if a company is able to export a lot, then he will get a lot of tax benefits. So what he did, he just put up certain empty boxes in the ship. and they showed that so many boxes have been uploaded, and then the ship will go a little, right, and then will dump all those boxes inside the ocean. But the record shows that you have exported, and hence you will get all those tax benefits. Right? So the similar thing is being followed now in the name of research and development. There is another stalwart, Naveri, found a positive and strong relationship between R&D and the growth of output or total factor productivity. Of course, he analyzed the data from the developed countries, where your research and development data is more authentic, unlike our data set. And he could show that no, there is actually a positive association. If a company is able to contribute to research and development expenditure significantly, that it will definitely contribute to growth and total factor productivity. Then the channels of diffusion of spillovers vary considerably. This is a very interesting theory, the spillover theory. What they argue that if one sector is undertaking innovation and if there is technological upgradation, it will immediately have a lot of spillover effects into the other complementary, vertically, horizontally related industries. You take the example of automobile. Automobile industry is the one, whether it is domestic or foreign, maximum technological advancement is taking place and has taken place in last 10-15 years. And you will be able to see that whichever industry, however small it is, whichever is associated with the automobile industry, horizontally or vertically, they are all upgrading their technology. Otherwise, the inputs or the other materials which they are manufacturing will not have a compliance with the automobile industry. So obviously they will have to upgrade their technology. So they may take the form of intra and inter-industry relationships. So once there is one technological upgradation in one sector, it can have significant spillover effects either through various industries or within a given industry you have subsectors. So across various subsectors also it is possible. Then interdependence between public and private sector investment. So this particular hypothesis emerged during the mid 80s and 90s. There is a book by Ishar Ahluwalia, Growth and Stagnation of the Indian Industry since the mid 60s. So what happened, if you look at the Indian experience, immediately after independence, the Mahalanobis strategy, second 5-year plan, Nehru-Mahalanobis strategy, they wanted to emphasize that we must become self-sufficient. We should not depend on the foreign countries. The moment you will depend on the foreign countries, again, financial, imperial, trade, etc. relationship will emerge, and again we will become the slaves of those countries. So let us try to manufacture the goods which we would have otherwise imported from the developed countries. So that is what is called as your import goods based industrialization, heavy goods based industrialization. The Nehruvian model envisaged that to prosper you must have your own nuclear plants, your own MIG factories, your own iron and steel industries, etc. So under the second 5-year plan you will find that most of these heavy goods industries were sort of created. And what was the hypothesis? The hypothesis was that once the base is created, it will have a lot of spillover effects. It will promote the private sector to come into the picture. But what happened? Soon after, almost 15 years, okay, in 51, 52, this kind of strategy was introduced. By mid-60s, 1965, 66, suddenly the industrial growth went flat. So it was a major shock to all of us that we just tried to industrialize, but within 15 years our industrial growth rate almost halved. So then people were trying to sort of identify the causes. The Rao and Patnaik hypothesis from JNU school emerged to say that actually there is interdependence between public and private sector investment. Once the public sector units take the lead and they create infrastructure, then only the private sector industries would come into the picture. So the institution of private property is very, very important. Suppose I have set up an industry and tomorrow the state government or national government says that it can take over. So then naturally I don't have any confidence to make more investment. I know that it can be gone, and that is the kind of fear most of the industries were suffering from. You take the note of the negotiations between Tata, one of the top industrialists of that period, and the then government. The then government, in principle, has adopted the mixed economy strategy. So they are saying that we will not encourage the private investors only. The public enterprise is going to take a lead role. But then Tata is constantly worried that if my estate, industrial estate, will be taken away by the government, then what would be my incentive to? Then the writings come up, the letters. There is a book by Arvind Panagadia which has been published very recently. So there he reveals that then the government is ensuring him with all private collaborations, etc., that you don't worry, we will try to give you all kinds of protection. You make investment as much as possible. So it is very important that the complementarity between the public and private investment must take up. Otherwise, the public sector will not be able to motivate the private sector to invest a lot and to raise the total factor productivity. If the private sector knows that public sector is competing with me, then they will never come forward. The public sector must invest in those areas where the private sector is not interested. For example, creating a bridge or certain other railway tracks, that should be the domain of the public sector, so that it can create a lot of complementarities. Supplier and purchaser connections. So this was a very, very major problem. The connection between the suppliers of the raw materials and the purchaser of the raw materials. Huge time gap, and the resources and the intermediaries who are put on. Now don't think that all these intermediaries have disappeared now. The intermediaries exist in a different manner. There are contractors. That suppose your Louis Philippe is trying to engage certain garment stitchers and trying to collect those materials from your neighborhood. So Louis Philippe will not negotiate with those local garment makers directly. There would be a wide range of intermediaries through which the resources will be supplied and again the final products will be collected. So in the process, what is happening? Lot of benefits, profits, etc. are being squeezed by the intermediaries. So it is very important that there should be direct connection between the supplier and the purchaser. Then what happens? The actual wage which you are paying to the local government makers will sort of directly transfer. And then geographical location. So geographical location is very, very important. You, particularly for a very large country like India, you should not be thinking that every industry, every product can be manufactured in every region. So there is a class of literature, particularly the urban economics literature, which to some extent overlaps with industrial organization theory, and there they try to argue that you must identify the potential of each region. That which region has a greater potentiality to manufacture which type of products. And if I have to just generalize in the light of Henderson's understanding, he says very capital intensive products should be manufactured in very large cities. Then semi-capital intensive goods should be manufactured in medium sized. Then relatively low capital intensive goods should be manufactured in the small towns, and the more labor intensive products like agriculture and allied activities should be manufactured in the rural areas. Then only you are able to save the resources. If you start cultivating paddy in a large city, then you are actually wasting the land and you are not able to get the actual benefit of that. So that is very important, the geographic location and the potential of each of the geographic location needs to be identified. Then only you will be able to work out a proper industrial map that which particular goods should be manufactured in which particular territory. Then as well as domestic farms and farms in other countries. So here one is trying to build a strong connection between the MNEs, the multinational companies, and the domestic companies. That in what way, even if you do not directly participate with the foreign companies, in what way certain kinds of information sharing can be encouraged, so that that information sharing will contribute to your technological advancement. Of course, they will not do it free of cost. So what are you able to offer them in exchange? So you say that, okay, certain parts of your product I will manufacture and I will give it to you. So you share the information with me. So they would realize that, okay, if certain parts of the products are manufactured in your country, then it will save my resources, it will save my labor. So that is what is the concept of your global value chain, supply chain. So one particular product will not be manufactured in one specific country. Parts of that commodity will be manufactured in certain countries, certain other parts will be manufactured in certain countries. So at every process, then every country is benefiting. Well, empirically whether that is true or not is a different question. I am saying from the theoretical point of view. Through the study, so OECD had, Organization of European countries, OECD countries had conducted a study, and there Nadiri noted that the diffusion of new technology is very rapid and transmitted not only through exports but also through FDI and MNE's research operations. So empirically he tried to provide some evidence to this theoretical proposition. He said that no, it is actually happening in the developed world, of course, not really in the developing countries, that whenever there is such kind of global value chain or whenever there is such kind of collaborations, it is benefiting both the developed countries, I mean those who are purchasing the product and who are manufacturing the product. So he justifies that FDI is definitely a determinant of the total factor productivity growth. He concluded that more than half of TFPG can be explained by R&D spillover effects, and that having more R&D investments will lead to further increases in R&D spillovers. So if you, let us say, a particular country has experienced 2% total factor productivity growth. 2% total factor productivity growth is quite significant. 9% growth may not be all that spectacular because resources might have been utilized to a very large extent, but 2%, 3% total factor productivity growth makes a lot of sense. So he says that you can actually undertake a decomposition exercise. How much of this total factor productivity growth is coming from technology spillover? How much of the total factor productivity growth is coming from other factors? So he says that a very significant part, at least half of the total factor productivity growth is coming from this research and development expenditure and also what you call as the innovation expenditure. One important conclusion which emerged from several studies: R&D activity is a channel for the diffusion of knowledge. So the moment you are innovating, you are opening a chamber that under the heading that research and development, it would automatically motivate you. I know there can be manipulations, but at the same time it will automatically motivate you to look up to other countries, entrepreneurs in other countries, what they are trying to do, and whether I will be able to replicate or not. Let me give you an example here. When in the 50s and 60s, China was as bad as India was. I mean, people who have witnessed 50s and 60s, they have narrated those stories, that even in the streets of very large cities, you could see some goats and ships were moving around, chickens were moving around. But from that phase till now, you would find that there is a huge journey. And now most of the Chinese cities, the large Chinese cities, would replicate your New York or New Jersey or some of the cities of the very developed world. So what they did, China realized that they have surplus human labor. They are not able to engage them in productive activities. So the government took the initiative to collect information from other countries, that those products should be cost efficient. That means it should not require huge amount of resources, but the moment it is manufactured, it can compete with other countries and it can sell well there. So when you go to an European city, you will find Eiffel Tower is being sold. So one set of Eiffel Tower, at the back it is written made in China. Another set of Eiffel Tower, at the back it is written made in Paris or made in France. Prices are hugely different. Made in China, €1. Made in France, €6. So as a traveler, as a tourist, you are not interested whether it is manufactured, made in China or made in France. You bring it and you put it in your showcase. So Chinese goods were sold significantly. So that is how the government collected the information on the marketability of a particular product. So they went around, Ganesha and Lakshmi for India, that's the best example, which are manufactured in China. They look much better, more impressive, and at the same time they have a huge marketability. So, that was the kind of initiative Chinese government took. I mean, irrespective of whatever negative criticisms we have against China, but this was the kind of initiative they took, and that engaged the human beings, human labor, productively and added to their total factor productivity. Even if we say that their figures are all manipulated, but these are some of the strategies through which they could actually enhance their total factor productivity. So one important conclusion which emerges from our discussion is that there has been research and development expenditure. Okay. So research and development expenditure which contributes to total factor productivity growth significantly, and also it has the ability to create diffusion. So once research and development expenditure gets enhanced in one sector, it will automatically encourage many other sectors to become. So widespread technology diffusion creates the possibility of increasing returns to investment. So you are always interested in the fact that if I am investing $100, I must be getting more and more returns. This year I get 5%, next year I should be getting 7%. So how is that possible? That is possible only when it is associated with technology diffusion. And what is the cause of technology diffusion? Technology diffusion can be realized only when you have R&D expenditure enhanced. So now we will try to, so we have now talked about, you please remind me of the first session, second session, third session, okay? What is the cutoff limit? So, the one important determinant is your technological progress, etc. Of course, there is a huge criticism to this particular standpoint, particularly your Amartya Sen. He wrote a paper in Journal of Econometrics, and he was trying to argue that this entire literature is not really very fruitful. It's all full of ambiguity. So there in that paper, he says that one of the disciples, dearest disciples of Buddha, Subhuti, he is born again on earth, and he has been asked to do this kind of an analysis. Then only he will attain Nirvana. So he is trying to estimate total factor productivity growth, capital series, labor series, which we will do a little later. And every time he comes back to Buddha, that this is how I have done the exercise, Buddha rejects, says that no, it's all rubbish, it's all wrong. So he tries to say that how would you make a distinction between capital and output? Suppose you have used a piece of wood to manufacture this table. Then next time when you are manufacturing another table, you are using this table to be your foundation, so that another piece of wood can be placed on this table and you will manufacture the second table. So that means your output becomes capital for the next series. So he tries to argue that all these arguments, etc., are full of ambiguities and it is not possible. So he tries to dismiss. Anyway, we are not going to that literature. That's a typical Marxian literature. We will try to subscribe to the neoclassical literature, where we say that it is possible to pursue on these methods, and it is possible to reap technological progress, and it is possible to realize the total factor productivity growth. Similarly, there was another Marxian lady from Cambridge University, Joanne Robinson. You might have seen her name, who talked about imperfect competition. The monopolistic competition concept was given by Chamberlain. Imperfect competition, almost the same concept, which was given by Joanne Robinson. The entire male folk was quite against her when she tried to do this. So she tried, the entire spectrum of male economists went against her and they tried to criticize her. But then she was extremely radical, and she wrote that I do not know what Solow is talking about, because Solow was getting the Nobel Prize at that time. So it is, he said, the difference between the output series and the input series is actually a residual. If you are aware of regression exercise, when you say y is a function of x1, x2, x3, x4, whatever is not being explained by x1, x2, x3, x4 will be captured by the error term, residual. So she said that it is all a black hole. It is Solow's black hole. I don't know what Solow is trying to sell to the whole world. Anyway, Solow was very angry. So Solow said that, well, the world cannot afford to wait till Mrs. Robinson comes up with her most desirable innovative methods. Let us go ahead with whatever we have discovered. So anyway, so this literature is full of the criticism, but nevertheless, we will, as a learner, we will have to believe one in particular standpoint, and that is what I am trying to do. So other determinants of total factor productivity relates to your agglomeration economies. What is this agglomeration economies? Agglomeration economies would mean that if more and more activities are being undertaken in one region, concentration will increase. So high level of concentration will get you more benefits. So if you are a potential entrepreneur, you are trying to ask this question whether I would invest in Rohtak or I would invest in Delhi. The advice will be you should go and invest in Delhi, because in Delhi you have more activities and therefore you would benefit in the process. They theorized, they sort of worked out the channels through which you will be able to benefit. So two important schools you will be able to see, Mills and Henderson, my supervisor. So the first paper from Edwin Mills came in American Economic Journal. So where he argued that irrespective of whichever activity you are doing, if you go to a large city where there are many people and many activities and a very large market, you would benefit much more than if you go to an isolated place. So which would mean that the firms which are located in highly concentrated pockets, they are the ones who would benefit more. You take the history of any country, take the history of Indian industries, you would find in the first phase they are all trying to concentrate in Mumbai region and Mumbai, Thane, Belapur region, slightly expanding slowly. So concentration not only strengthens the forward and backward linkages, but also reduces the cost of operation. You want to buy some information, buy some raw materials. So immediately the supplier will be there. A little while ago what I was trying to tell you, that the supplier and the purchaser should be face to face. They should be closer to each other. So in a large city it is possible to have a strong link between the supplier and the purchaser, which is missing in the remote areas. Similarly, you will find the effective price of infrastructure. Suppose government says that, okay, I will provide you a railway track, okay, for your company, but you will have to share the cost. So what is happening? There are 5 industries which would benefit from that creation of the railway track. So government will say that, okay, each of you then contribute this much. So because there are many users, it will be that the cost will be divided among those users. So in all, interdependence of industries in terms of input-output linkages, ancillarization and availability of infrastructure contribute to the growth of agglomeration economies. So the crux of this theory is that you should try to create such spaces where you have concentration of activities. At a later stage, we are able to see the concept of SEZ. SEZ is what? Basically creating those special economic zones, where your rate of return in investment is going to be much higher compared to in any other place. Export processing zones. So each company would decide that what is my potentiality, and then accordingly it would decide that where I should go and where I should invest. So here you were able to see that Hermansen brought out a number of reasons that why the agglomeration benefits, we call them as agglomeration economies. Agglomeration benefits can be higher in the concentrated place. this. There is slight difference between Edwin Mills' concept and Henderson's concept. Edwin Mills said that whatever activities you are doing, you are manufacturing chemical goods, I am manufacturing iron and steel, all of us should come and do it in one region, Gujarat model. Henderson is saying, no, it's not concentration of all kinds of activities, concentration of specific type of activities. You are engaged in ICT, I am engaged in ICT, we should go to Hyderabad or Bangalore. That model, ICT model. So that is the kind of thing that Hermanson has made a distinction between these two. So Mill's concept is called urbanization economies, Henderson's concept is called localization economies. Okay. So both are agglomeration economies, but conceptually they are slightly different. So we have some evidence to show that large cities usually experience higher levels of productivity, total factor productivity or technical efficiency. In whatever way you are trying to measure, there is some evidence. But when I was doing this experiment, I could see that there is not a steady linear relationship. As size increases, productivity increases? No. Till a certain point it increases. Then beyond a certain point, it starts stepping off. That means every city would have a maximum saturation level or a saturation limit. So what is that limit we have to figure out? Like if you recall, Rajiv Gandhi way back said Calcutta is a dying city because state government is not pouring in enough infrastructure, so returns are less, so the new farms were not going to that city. Though in the first phase of industrialization, West Bengal was an industrial city. So a dying city in the sense that the total factor productivity growth is coming down. Okay. So therefore no farm would try to go and invest there. On the other hand, Gujarat model was throwing up much more prospects. So that is how you were able to see that the Western India progressed in terms of industrialization to a much faster rate compared to any other area. Though to begin with, most of these areas, South, Tamil Nadu, West Bengal and Maharashtra, all three were taken. So higher levels of urbanization and TFPG, we are able to see that it goes up, there is a positive relationship, but then beyond a certain point it starts tapering off. Then another most important point is your trade openness. That if you pursue greater trade association with other countries, then you will be in a position to experiment higher productivity. Because what will happen, suppose you are exporting. So you manufacture a particular good, you sell it to the other country. Those countries feel that no, your quality of product made in India is kind of taboo, so we don't want to buy. You realize your mistakes, so you try to improve the quality. Improving the quality means what? Total factor productivity. You will try to raise the competitiveness of your product. So that greater trade openness is said to be the important strategy for raising your total factor productivity. Similarly, imported inputs. Recently, you must have seen in the newspaper, the government has given a lot of benefits in the last budget, gave a lot of benefits to the companies to import raw materials, to import other inputs from other countries, basically to encourage them to experience total factor productivity growth. Empirically, we get to see there is mixed evidence. In certain industries, yes, trade relationship contributes to total factor productivity growth enhancement significantly, but there are certain other industries where in spite of having good trade relationship, they are not able to work on total factor productivity growth. So the public infrastructure, I have already mentioned that public infrastructure has been identified as the most crucial determinant. The entire Northeast. Why there is no industrialization? Why there is no total factor productivity growth? That is precisely because you do not have adequate infrastructure. So in this particular study, when I was collaborating with my other collaborators from World Bank, so we could see that physical, financial and social infrastructure. We tried to collect information on 3 different types of infrastructure separately, and we could show that social infrastructure has a tremendous impact on total factor productivity growth. Social infrastructure means educational level of the available labor force, its employability, skill levels, educational attainment, health also. These are the important aspects. We usually think that it is the physical infrastructure. True, physical infrastructure is important. The financial infrastructure is important. If it takes months to receive a dollar encashment, then naturally your business will flop. So the financial infrastructure is important. But what is more important, we could identify here, is your social infrastructure. So health, education is the key determinant. And then the human capital investment plays a pivotal role. So the social infrastructure and human capital investment, they are basically the related. Pivotal role in driving TFP growth. Studies by members of Asian Productivity Organization reported positive effects of quality change in labor on TFPG due to higher education level for most countries. See, after the Second World War, when Japan realized that we actually do not have full freedom, because US said that military would be under our control. You invest on human capital and other development indicators, we will give you resources. But after the Second World War, Japan absolutely, even as of today, they do not have the military freedom. So Japan then tried to create an influence on the rest of the world. How they could do it? It was through the creation of Asian Productivity Organization, which is a Tokyo-based organization. And they motivated most of the Asian countries that you become a member of our Asian Productivity Organization. So initially what happened, the entire East Asia and South Asia became member. Like Ministry of Industry and Commerce, our the central ministry, it has a wing called National Productivity Council, NPC. So most of these East Asian and South Asian countries, they have NPC or NPO, that is National Productivity Organization. So their main objective is to follow the orders of this Asian Productivity Organization. And APO tries to argue that we have less resources, so let us not think of using up those resources. Our main objective is to create opportunities to use less and less resources. That means your total factor productivity growth should be enhanced. So their argument is that you spend a lot on human capital formation, on improving the levels of skill. On the job training is a must. For casual workers, you should have certain training programs. That will give them the flexibility to work and also to nurture yourself to diversify in various activities. So these are, and then finally we talk about the ICT, which I had already mentioned in the theoretical literature, and we are able to see that ICT has been playing a major role. So the ICT-led development based on the notion that investments in ICT can accelerate economic growth and can also contribute to total factor productivity growth is sort of established. So if I have to summarize, what are the factors that I have talked about? I have talked about the trade relationship, I have talked about the physical infrastructure, social infrastructure, human capital formation, and then the agglomeration economies. That is, which region has a greater potentiality that needs to be identified. Usually in the textbook you will find concentration is a bad word. We had MRTP. Okay. But here in the agglomeration literature, one is saying that actually concentration is beneficial. If you have more concentrated activities, of course it will lead to distorted development. One region will develop at a much higher level compared to another region. But from the point of view of total factor productivity growth, you will find that the regions which are more concentrated will definitely benefit in terms of total factor. So that would be our first session. Okay.
You will also, we may take a tea break.
We can take a tea. Thank you. A short tea break and then we will be on. So the country is what? GDP is basically a value added. That is contribution made by capital and labor. On the other hand, you can have another concept, that is output, total output. Total output is the contribution made by capital, labor, energy, material. All the factors of production are included. So there is a basic distinction between output and value. As I mentioned to you, The factor productivity are easy to measure. That value added divided by capital, value added divided by labor. These are all your factor productivity. Okay. Maximize. Okay. Or you can also take output divided by capital, output divided by labor. These would essentially give you some reflection on the factor productivity. And then I mentioned to you that TFPG is conceptualized as technological progress or technological regress plus the change in technical efficiency. dTE upon dt means the change in technical efficiency over time. dy by dx जो आप use करते हैं, so that is dTE upon dt, that is the change in technical efficiency over time. So if technological progress becomes negative, then you know it is technological regress. But we expect that technological progress will happen over time, so that we will be able to enrich ourselves over time. Now, how do you estimate? One point, easiest method is called growth accounting technique. Growth accounting technique, you take the rate of growth in value added minus, within bracket, you have the weighted combination of the rate of growth in capital and rate of growth in labor. So, if you have a series in capital, if you have a series in labor, you can easily calculate the rate of growth in capital and rate of growth in labor. But remember, when you are calculating the rate of growth in capital, it has to be in constant prices. Otherwise, inflation is happening. So every year you have inflated values, so you will have to net out the effect of prices. So you convert the series in constant prices and then you calculate the rate of growth in capital. Similarly, when you are considering the rate of growth in value added, value added should be considered in constant prices. You should not take in current prices. Now the question is, what is this W1 and W2? These are the two unknown things. So if the capital series is given, labor series is given, value added series is given. So you will consider up to these three series, but what is W1 and W2? We will come to that. Then here you have, if you are considering output, then what you do? You consider rate of growth in output in constant prices minus the weighted average of all the inputs. Rate of growth in capital, rate of growth in labor, rate of growth in material, rate of growth in energy. And what are the weights? A1, A2, A3, A4. So the whole question is that how do you work out those weights? So that is the crucial point. I will come to that. Then you are also assuming there is constant returns to scale, because you don't want to give the benefit to an enterprise which may be in its initial stage and therefore it is experiencing increasing returns to scale, or an industry which is very old and it has been surviving in the market for a very long time and therefore it is experiencing decreasing returns to scale. No, we don't want to consider that. We will be considering the assumption that there is constant returns to scale, so that on an average you are able to see what is the difference between value added growth and the input growth for these industries. So this is a crucial assumption. Now in growth accounting technique, what you do, as I mentioned, that this is the formula. So you will have to work out the W1 and W2. Okay. So W1 and W2, the weights must always add up to 1 in such calculations. Okay. So if I know W1, automatically W2 is known to me. So how do I calculate W1? W1 is relatively difficult to calculate. Okay. Because W1 is the share associated with rate of growth of capital. W2 is relatively easy, which is the weight associated with the rate of growth in labor. So how do you do it? You take the wage rate, multiply wage rate in constant prices, wage rate, multiplied by the total number of laborers divided by value added. Okay. So that gives you the weight. So what you are assuming, that labor price per unit into the total amount of labor plus capital price per unit into the total volume of capital should be equal to value added. So if you divide both sides by value added, on the right hand side you get 1, on the left hand side you have the share of labor and share of capital. So share of labor is easy to calculate. Once you do that, then automatically 1 minus share of labor will be equal to the share of capital. So you do that. But here there is one problem. You have a series, let us say starting from 1980 to 2024, value added capital labor. The share of labor and share of capital is changing over time. It is not fixed. So how much labor share for which year should be taken is a key question. Now some methods would say that okay, in the initial year, in the first year, what was the share of labor? You consider that. So suppose labor share was 40%. So then you will say 60% share is for capital. So 0.4, 0.6. W2 is 0.4, W1 is 0.6. But some people say that no, initial year is very old, 1980. After that, lot of changes have taken place. The share of labor and capital have changed drastically. So maybe you should take the average of W1 and W2 or whatever. I mean, there are a lot of debates on that which share one should be considered. Anyway. So the growth accounting technique, as I will show you in the Excel sheet, is relatively easy to calculate.
So as we are fixing the price constant, then it means we are taking the inflation out of the picture.
Yeah.
So how can we take the inflation out of picture? How can we fix the constant price?
You can work out in this manner. You can look at the price index. We have the wholesale price index and also we have consumer price index. Maybe the wholesale price index would be more appropriate in this context. So you can look at the movement of the prices. Okay. So suppose in 1980, suppose it was 100, then it went up to 120, 150, 200. Likewise, you have the series. So you take that series and deflate the figures for value added. Suppose my income today is $100. Yesterday also it was, one year before it was $100. It doesn't mean the value is same. If you adjust for inflation, 100 may become 90. So that means my actual income has declined. Or if my income is now, let us say 150. So you may say that even in real terms it has increased. It may not be 150, 100 after price adjustment, let's say it is 130. So that means there is a real increase. So from the price series, you can essentially deflate. So of course it is very important that how would you calculate the capital price series, how would you calculate the value added price series. It's a very, very important question, because capital is not a homogeneous commodity. You have several inputs in the domain of capital. You have land, you have machinery, you have many things. So you can combine those prices. You take the land price, you take the building price, you take the machine price, etc., and then you try to combine them and form a general price, okay, for capital, and then use that series to deflate the value of capital. It's a simple rule of thumb. Suppose you say today's 120 is actually equivalent to 100 of the initial year. So suppose in terms of prices. So suppose today you are using 5 million rupees of capital. So 5 million multiplied by 100 divided by 120. So it will be reduced. So that is the price of, today's price in the initial year's price. Current price is being converted to constant price. Okay. So under the assumption of constant returns to scale and then apply growth accounting technique. Okay. So there is another important technique, because W1 and W2 calculation is little difficult, that which specific share you would consider, whether the share in the base year or share in the terminal year or share of the averages, which one is to be considered. Since there is some confusion, people say you follow the semi-econometric technique. In semi-econometric technique, what happens? You take the value-added series in constant prices, capital series in constant prices, labor is number of hours or number of human beings, and then you regress. Okay. So when you regress log of value added on log of capital and log of labor, these two coefficients will be estimated. So these two, and when you are imposing the constant returns to scale assumption, then automatically W1 plus W2 will be equal to 1. So the regression should not be an unrestricted regression. The regression should be a restricted regression, that when you are regressing log of value added on log of capital and log of labor, you give a command that coefficient of capital and coefficient of labor should be equal to 1. So once you put that restriction, you will get the W1 and W2. Okay. So once you got that, then you calculate the rate of growth of value added minus W1 is known to you, rate of growth of capital is known to you, W2 is also known to you, and rate of growth of labor is also known to you. So then you can work out the residual. Okay. So the difference between growth accounting technique and the semi-econometric technique is important. In the growth accounting technique, you are completely ignoring the fact that base year or middle year or the terminal year shares are these share, which specific share will have to be considered is not really known. Okay. In the growth accounting technique, you are being confused about that whether to take the base year shares or the terminal year shares or the middle level shares, you do not. Whereas in the semi-econometric technique, you are able to identify that which specific weights should be considered, because on an average the coefficients of capital and the coefficient of labor will be given, and those are the shares of capital. Okay. So that is why some people prefer semi-econometric technique over the growth accounting technique, because of this confusion that W1 and W2 need to be worked out. Then comes pure econometric technique. In pure econometric technique, what happens? You regress log of value added on log of capital, log of labor, okay, and you have an additional term. Additional term is your trend, time trend. Time trend, how do you fix the values? 1, 2, 3, 4, 5, 6, that way. Okay. Your year, let us say, starts from 1980, goes up to 2024. So if it is a continuous time series, you just assign 1, 2, 3, 4, etc. Okay. Annually. So you are regressing this log of value added on log of capital, log of labor, and you have a time trend, that is T. And that coefficient of T would essentially give you the rate of total factor productivity. Of course, you will have to again impose a restriction that there is constant returns to scale. That is, share of the share of capital and share of labor, or the coefficients of log of capital and the coefficient of log of labor must add up to 1. So that means you are ruling out the possibility of increasing or decreasing returns to scale. There is only constant returns to scale. And you are not making any assumption that whether W1 will pertain to the base year or middle level year or terminal year. On an average, what would be the share? The data will speak for itself. You are not imposing any restriction. So from that point of view, every method has some advantages and disadvantages. Okay. And then this is what is called as the residual. Earlier in growth accounting, what was happening? You took these terms to this side, and rate of growth in value added minus the weighted share of capital growth and labor growth. Okay. Now what you are doing, you have incorporated this term T. So that coefficient of T will essentially give you the rate of growth and productivity. Suppose the coefficient of T is 0.025, 0.025. Multiply it by 100, how much? 2.5. So 2.5 is the rate of growth in total factor productivity. Suppose it is minus 0.001. What does it mean? That means multiply it by 100, that becomes minus 0.1, isn't it? So total factor productivity growth is declining at a pace of minus 0.1. So not necessarily, as I was discussing in the first lecture, not necessarily total factor productivity growth will always be positive. It can be 0, it can be negative, it can be anything. minus 0.015, multiply it by 100, minus 1.5. So total factor productivity's growth is actually declining at minus 1.5% base. So this is what I did. G into 100 is the TFPG in percentage terms. But here you must remember that this kind of an exercise can be done only when you have pure time series data. Time series data in the sense, for a given industry, let us say chemical goods industry, a particular firm is manufacturing chemical goods. So you have the information starting from 1980 to 2024, and then you calculate these values. The problem arises when you have a cross section of firms. In a given industry, suppose iron and steel industry, there are some public sector units, there are some private sector units. So you want to compare. In the public sector you have SAIL, Steel Authority of India, and then in the private sector you have Tata as the giant company. So you would like to compare that whether public sector is doing well or private sector is doing well. Similarly, in certain your machine tools, you have a large number of firms. So who is doing better compared to the other? That is a very important question. So that in a cross section, you cannot estimate TFPG. TFPG is a flow concept. It can be estimated only over time. But when you are considering the cross-sectional information, you can essentially estimate the relative performance, the relative efficiency, whether you are utilizing the resources to the best possible extent or I am utilizing the resources to the best possible extent. What is our relative efficiency? Whether it is yours is 80% and mine is 70%. So that is what can be calculated through technical efficiency. But here when we are considering these three methods I mentioned to you, one is pure growth accounting technique, another is your semi-econometric technique, and the third is your pure econometric technique. Okay. So in these three estimates you can essentially work out the total factor productivity growth. And let me tell you that not necessarily these three methods will give you the same results. The methodological differences will have a significant impact on the estimation. Because TFPG is very, very sensitive to two things. One is methodology and the other is the price that you choose to convert them into constant prices. To convert the series into constant prices. Suppose for capital, I am taking the machine tool price to deflate the capital series. You are considering a weighted average of machine tools, plants, buildings, land, etc. So your price index and my price index are very different. So when we are converting the capital series by two different prices, the magnitudes will be different. And then when we are estimating the TFPG, the results will be very, very different. Okay. So it is very, very sensitive to the selection of prices and the kind of function or the kind of methodology that you choose. Usually you will find that the growth accounting estimates are very different from the econometric methods. So it is up to the researcher. Then you will have to decide which one you want to use. Of course, growth accounting will have certain advantages, I will tell you later, compared to the econometric method. But econometric method might give you a better estimate compared to, more realistic estimate compared to the growth accounting estimate. Okay, so let me tell you here. How would you advantage of growth accounting technique over the econometric or econometric technique. Here in the growth accounting technique, what is happening? You are able to do the analysis, the estimates for each year. Between 1981 and 1980, what was the growth rate of value added? What was the growth rate of capital? What was the growth rate of labor? And you have the share of labor and share of capital. So then you estimate. Then between 81 and 82, what was the growth rate in value added? What was the growth rate in capital? What was the growth rate in labor? And you have their weights. So again you get a figure. Okay. So for each year over its preceding year, you are able to get a total factor productivity. So suppose between 81 and 80 it is 2.5, between 82 and 81 it is 1.5, between 83 and 82 it is minus 1.1. So likewise you will be able to see the rate of growth in total factor productivity over each year. And now you can essentially plot that, and you can see that how the growth rate in total factor productivity growth is behaving, whether it is following an increasing trend, decreasing trend, or a highly fluctuating trend. All that can be deciphered. So that's a great advantage of having total factor productivity growth estimates for each year. Whereas if you are applying the econometric technique, you will be able to get only one figure for a particular period, because you have the average rate of growth of value added between 1980 to 2024. You have the average rate of growth in capital over this period and of labor over this period. And similarly, you have the average labor share and average capital share as estimated from the econometric technique. Okay. So if someone is asking you, I want the figures for each year, then you will not be able to work it out through pure econometric method. You will just present one figure, that during this period 80 to 2024 the growth rate has been, let's say total factor productivity growth rate has been 1.1 or something like that. Okay. However, you can divide the entire period into certain sub-periods. So 1980 to, let us say you take 1990 as your deregulated regime or something like that. Deregulated regime is actually from 1984 onwards. So anyway, you can take the 80s, then 91 to, let's say, first phase of reforms, then after 2005 or 6 you can take another phase of reform. Likewise, you can divide the entire period. Then for each sub period you can calculate the total factor productivity growth, even if you are following the pure time series method, pure econometric method. Okay. And then the question is, if you have the growth accounting technique which estimates total factor productivity growth for each year, how would you answer the question, what has been the average rate of growth in total factor productivity for this year? If you are following an econometric method, you have the average rate of growth. But if you are following the growth accounting technique, you have individual year-to-year rate. And you cannot average the year-to-year growth rates. Suppose I say in last 1 year growth rate was 1%, then it was 1.1%, then it was 2%, then it was 3%. If you add them and take average, that is wrong. Because exponentially you will find that in such methodology only the last figure and the first figure will emerge. All in between figures will be dropped out. So it is wrong to take any average of the growth rates. You should rather follow the pure econometric method to get the average growth rate, or what you do the growth accounting technique and then you index the productivity. How do you index? So you say that the first year productivity is, let us say, 100. And now you, from the growth accounting technique, you know the growth rates over years. Between 81 and 80, let us say it is 1.1%. So in 1980 it was 100, index is 100. 100 will become 101.1. Likewise, you prepare an index of total factor productivity, not growth. Okay, index of total factor productivity. And now you regress log of productivity index on time trend. This coefficient will give you the average rate of total factor productivity growth over this period. So I would say that growth accounting technique has both the advantages. It can give you year-to-year growth rates, and from that you can also calculate the overall average rate of growth in productivity. Whereas the pure econometric technique will give you only the average total factor productivity growth rate over a period, but it cannot give you the year-to-year growth rate. So pure econometric technique may be more appropriate, but it is not able to give you the year-to-year fluctuations and the average both. Whereas your growth accounting technique can give you both. Okay. Now we come to pure cross-sectional study. In pure cross-sectional study, what you are imagining that your technology is given. Technology is given, so there cannot be any change in technology. Because technological progress is an intertemporal concept. You will work for 6 months, then you will be able to realize that there is a change in technology. Okay. So unless you sort of pursue your innovation, you will not be able to experience the technological progress. So in cross-sectional study, we are saying there is no technological progress. Technological progress has come, is given. So technology is given, and then you are trying to see that which firm or which industry is using that technology to what extent. Your firm is using maybe 70%, my firm is using 60%. That is what we should be able to estimate. And that is also a very important exercise. Like there are some industries where you will find most of the firms are much below the frontier. That means they are not able to exploit the technology at all. And then there are some firms where you have very good leaders, where performance is almost 90%, 95%, and then there are some firms which are performing at a very moderate level. Then you will try to see that why one is doing so well and why another is doing so poor. You will be able to then identify. So it is very important to estimate the technical efficiency. So how do you do that? So here we use the concept of stochastic frontier function framework. Some people use linear programming, that is called data envelopment analysis, okay, DEA. But here what I have proposed is called as your econometric approach, that is stochastic frontier function approach. In stochastic frontier function approach, you are imagining that there are two types of errors. One error is basically represents the random error. Okay. So whenever you are regressing one variable on certain other variables, you will never be able to explain 100%. So there would be some discrepancy, and that discrepancy is captured through certain error, and that error follows a normal distribution. But when you are subscribing to this particular method of stochastic frontier function framework, there you will imagine that there is an additional error term. That additional error term, how it is emerging, we will pose that question later, but it exists. And that is the reason why your efficiency is 70% and my efficiency is 60%. So that is what we are denoting in terms of U. So this V is nothing but V is the random error, which will always be present in any econometric exercise. But this U is basically representing that why your efficiency is 70% and mine is 60%. So our objective will be to estimate this particular E. And then we can index them. The best performer can be taken as 100, and then the worst. Accordingly, the other performers can be indexed. So if your performance is, let us say, 90%, then accordingly I can work out the performance of the other firms. So, but here one important point is that when you estimate these equations, this will have stata. Does it have stata? No, it doesn't have. I have stata. So okay. So what happens? Our basic purpose is to estimate this U. So when you have to estimate this U, you will have to subscribe certain econometric properties to that distribution, because V follows a normal distribution. Okay, that is known. A random error follows a normal distribution. But U is only one-sided distribution. That means your performance of we are trying to estimate the performance of each other. Our performance cannot be more than 100%. 100% is the cap. So how much below we are is the important question. So that means that U will follow only one-sided distribution. You cannot be greater than 100. You will be always less than 100. So we say that in technical term, we say that U would follow a positive distribution, one-sided distribution. So one-sided distribution, that means we will have to tell the computer, each package will have certain alternative methods. So stator will have all these optional methods, exponential, gamma, half normal, etc. These are all positive distributions. So you will have to click on that to say whether it follows an exponential function or a gamma function, a gamma distribution or a half normal distribution. And then accordingly you will estimate the problem is, if you are saying U follows an half normal distribution and I say U follows an exponential distribution, then the efficiency that you have calculated and the efficiency that I have calculated can be different. Now, the Kalirajan had a very interesting paper. So he was trying to do the estimation for different farmers, and then he was trying to figure out that which farms are more efficient compared to the other ones. And his finding was very interesting. He would show that the efficiency indices are not very sensitive to the selection of the distribution, which is a consolation for us. That means whether you are choosing half normal and I am choosing exponential, our relative ranking will remain the same. Maybe our magnitudes are different. One would say you are 90% efficient, I am 80% efficient. When I am using another distribution, it would show you are 91% efficient and I am maybe 79% efficient. Ranking is same. You are still the top. I am below that. Okay. So the Kalirajan pointed out that irrespective of whichever distribution you choose, there is a robustness in the efficiency estimates. So from that point of view, one can select some of these properties and you can go ahead. You can, in fact, if you have a data set, you can do the experiments also. Once you choose exponential and work out the efficiency index. Next time you introduce the half normal distribution and work out the efficiency index and try to compare them whether the relative efficiency indices are different or same. Then the most important thing is your panel data. Panel data means, let's say there are 100 industries. For each industry you have 10 years of data. Okay. So 100 into 10, 1000 observations you have. So you have 2 times the difference between you and me is changing. So all that can be captured through panel data if you have panel data. Okay. So it would tell us the technical efficiency at a given point in time. It will also estimate the total factor productivity of a given industry over a period of time. It will also tell us the difference in technical efficiency between 2 firms over a period of time. So 3 things can be captured. Okay. So panel data estimation is the most appropriate one, though this is the most cumbersome. How will you do it? Okay. Basically, in panel data estimation, what you do, the growth accounting and your econometric methods I have explained to you. In panel data, what you try to do, you first try to regress the log of output on log of various inputs for each of the industries over a period of time. That is why you can see 2 subscripts. Okay, I, J, and then T is also there. Okay, so let us say I is your different form. Okay, J represents different inputs, capital, labor, material, energy. Okay, I represents different forms and T represents time dimension. Okay. So for each form you have intertemporal data. And then you are imagining that this aggregate error term is basically composed of 2 error terms. V, the normal distribution, and U, which follows a one-sided distribution. But the interesting point in panel data that you don't have to specify a certain distributional property to U. In cross-section, what happened? You have to believe that either it follows a half normal distribution or exponential distribution or gamma distribution, okay, the positive distributions. But here, when you are dealing with panel data, you don't have to subscribe to that kind of an assumption. It is all n relative terms. You will estimate this equation, and then you will get the error terms. Okay. Now this error terms, estimated value, like when you are regressing, the difference between observed value and the estimated value is the error term. So you get the error terms. Now this error term will be regressed on t and t square. So which would mean that the change in technical efficiency can be non-linear. If I say that this error term is a function of t only, it would mean that over time it is either increasing or decreasing, which is a very strong assumption. That should not be entertained. What do you presume? That it may rise and fall, it may fall and then rise. You allow the data to speak. You don't impose any kind of strong assumption. So that is why you take the error term and then you try to regress it on t and t square. So that will essentially, based on that, you will figure out which form is the most efficient one. And when you are doing this exercise, what you will do, you will consider each industry or each firm separately. Suppose we subscribe to the earlier example, there are 100 industries, and for each industry you have 10 years of data. So for each industry, you do this exercise. This equation will be estimated for all industries, all observations, that is 1000 observations. Then you take each industry separately. 100 industries, so 100 times you do this equation. But there are commands, in one go you can do 100 equations. So one equation will represent one industry. So for one industry you have 10 years data. So error will be regressed on t and t square for one industry. For second industry, again you regress error on t and t square. Okay, likewise. And then you will be able to calculate the technical efficiency and the change in technical efficiency as well. Okay. So this is, and this is considered to be, though it is little difficult, but this is considered to be the most appropriate one as far as your estimation of total factor productivity growth is concerned. And the interesting point here is that you are able to decompose the total factor productivity growth in terms of technological progress and change in technical efficiency. The coefficient of t in this equation, when you have done your regression based on 1000 observations, will give you the technological progress. Your only strong assumption is that you are believing that technological progress is same for all the industries, which is fine. In a globalized economy, once a knowledge is penetrated into the economy, it can be disseminated soon. So not necessarily your knowledge base and my knowledge base would be different. So everyone would be able to access that information. So technology can be same for everyone. So technological progress coefficient would be uniform for all the industries, or in a given industry for all the firms. Okay. So this coefficient of t multiplied by 100 will give you the rate of technological progress. So suppose it is 0.025 multiplied by 100, it would be 2.5. So 2.5 is the technological progress. Suppose it is negative, it would mean there is technological regress. Okay. So at what pace the technological regression has taken place, that can be identified. And then when you are doing these regressions, that where the error is regressed on for each industry or each firm separately, when you are doing it, there you will be able to identify the efficiency for each industry separately. Then you pull them together. Okay. So you have done for first industry, you have done for 10 years, for second industry you have done for 10 years, and you put them in one column. So now you have these estimates of technical efficiency. In that column you try to see which one is the best performer. You take 100 for that, and then for the rest you accordingly do index. And now from that you can also measure the change in technical efficiency over time, how a firm is behaving, whether its technical efficiency is remaining constant or it is changing. That can also be done. So that is why it is able to decompose the total factor productivity growth in terms of technological progress as well as changing technical efficiency. Whereas if you are using the time series method, then you will have only total factor productivity growth as a combined effect of technological progress and changing technical efficiency. You cannot decompose them. On the other hand, if you have purely cross-sectional data, then you have only technical efficiency of firms across firms given the technology. You cannot estimate anything over time because it's only a cross-sectional data. So anyway, all the three methods are important and it can serve our purpose in different contexts. So as I was mentioning, estimation can be done for all firms in a given industry. You take a specific industry machine tool, take 200 firms, work out their technical efficiency, or for all industries in a given country, that is also possible for different groups of industries, or for a given industry or aggregate manufacturing across countries, that is also possible. Like we had used the UNIDO data to do the total factor productivity growth for different countries, developed countries, developing countries. Okay. Now deflation of nominal series, the question which you were asking. That I told you that how to sort of deflate it, that arithmetical problem, that you take the current value, multiplied it by the base year index divided by the current year index. So that would give you the deflated series. Fine. But the question is whether you should consider a double deflation method or a single deflation method. So when some people use the output price series to deflate the value added, because value added is defined as the contribution made by capital and labor. Okay. But in real world it is very difficult to make a distinction between value added and output. Output is perceivable. You can understand, okay, this much output has been produced. So value added is not perceivable directly. You will have to calculate it. How will you do it? That is output value deflated, of course, minus the value of the material and energy. Then only residually you will know what is the contribution made by capital and labor. So it is a conceptual sort of idea. It's not exactly directly measurable. So therefore you will have to deflate the value added. How would you deflate? Value added price is not available anywhere. You will have output prices, you will have input prices. So some people take the output price series and deflate the value added series. But that is wrong. It's not wrong, I would say it has certain problems. In the sense, there is a strong assumption involved. It says that if you are considering the output price series to deflate the value added series, you are assuming that the material prices and the value added prices, they have moved at the same pace, which is not correct. Material prices might have moved in a different pace. So the double deflation method can be more appropriate. So what you do in double deflation method, you take the output series and you take the output price, deflate it. You take the materials for a given industry separately, take the material price, deflate the material quantities by the material price index, and then from the output series, deflated output series, you net out, deduct the deflated material series. Then you will get the deflated value added. This is what is called as double deflation method. So in double deflation method, you are deflating the output by output prices, deflating the inputs by input prices other than deducting one from the other, and what you get is the deflated gross value added. Whereas in single deflation method, you assume that output and material prices are moving in the same manner, and then you follow that. Then there is also considerable amount of research to determine the impact of TFPG on well-being. I mean, estimation of TFPG is one important point. And then in the second stage, you can also work out the determinants of TFPG or determinants of technical efficiency. That why one firm is performing better than another firm, why one industry is performing better than another industry, or over time, what are the determinants of TFPG. All that can be done. Also, what is important that you can assess the impact of TFPG on certain other important indicators. If TFPG is improving, whether our well-being levels are also improving. If TFPG in a given industry is significantly high, whether the employees are also getting higher remunerations, whether their wages and salaries are also improving significantly. Because after all, we would presume that if the performance of an industry goes up, then naturally it would have positive spillover effects on the well-being levels of the workers. So whether in terms of work conditions, in terms of wages and salaries, the performance is increasing or not, that one would like to figure out. Similarly, at the economy-wide level, if your total factor productivity growth is taking place at a very rapid pace, whether the standard of living of the population is increasing or not. In many developed countries, you would find that their TFPG growth rate was very high, and at the same time, people also benefited. In the developing countries, your TFPG growth is sluggish, and therefore your well-being levels are also not improving fast. So that is another line of research which has attracted a lot of attention. Then you would also like to see what is the ownership pattern, whether the public sector units are performing better or private sector units are performing better. Why public sector units are not able to compete with the private sector units? That can be one. Why Tata is doing much better than the units which would come under Steel Authority of India. So all these questions are very, very interesting. Like in pharmaceutical industries, you would find that the private sector units are performing much better than the public sector units. And the private sector units, why they are performing better? Because they are able to innovate to a large extent. Research and development expenditure in the private sector units in pharmaceutical industries is enormously large. Whereas the public sector units are not able to pursue innovation at that pace. But most of the incentives are going to the public sector units. Very sort of asymmetrical decision. So this is another class of interesting literature. Similarly, you can relate it to demographical studies and also your labor market studies. Regions where total factor productivity growth is very high are whether experiencing higher rates of population movement, migration. We say that people are quite well informed. I mean, my uncle has migrated to Delhi, so I contacted him, I figured out the information, and then I also migrated to Delhi. So they say that information flow is very significant and migration decision is taken very rationally. So if that is true, then we need to figure out whether migrants actually move to the regions where the total factor productivity growth is very high. If that is true, then we should be able to see that the wages in a region where total factor productivity growth is much higher than the wages in the region where it is total factor productivity growth is very high. So these kind of studies have also been undertaken to a very, very large extent. Okay. And then there is another class of literature which says that why the firms are not able to pursue a lot of innovation expenditure. That is because their TFPG performance is very poor. We say, yes, if innovation is high, TFPG will be high. But then you look at it from a different point of view. Only when I have surplus resources, when my TFPG is high, then only I will be able to spend. Right? So in the next round, what becomes important is your TFPG performance. So if TFPG performance of a country or firms is very poor, then naturally they will not be able to contribute to more research and innovation. So that is also another way of looking at it. Another issue is that how do you aggregate? Suppose you have estimated total factor productivity growth for steel industries, for chemical goods industries, for machine tools industries, for garment sector, etc. Now, how do you combine that? That's a very important question. So there are many different methods. So one is your Domer aggregation. That I think is the simplest form of aggregating it, and then you can come up with one specific index that this is the total factor productivity growth for all industries for a given country. Okay. So with that, let me take you to some Excel exercises. And first I will do the growth accounting, which I can do in Excel. Then I will take one step. See, can you see? This is my value added, and this is my capital, and this is my labor. Whatever the units are, because we are not bothered about the units. Measured in labor is measured in terms of hours or in terms of number of workers, and capital is measured in terms of value of capital. Value added is measured in terms of again value. So let's say we have already deflated the figures. Deflation I have already explained to you. I am not going to show you the deflation. So these are deflated figures. So what I do, I consider take log of all these variables. Log of value added, log of capital, log of labor. Great. So I am following the growth accounting technique here. In following the growth accounting technique, I need to have the labor share, that is the coefficient of labor growth. Then I would have the 1 minus that would give me the capital share. So to calculate the labor share, what do? I need wage rate. Okay. So wage rate is given to me. Okay. Then I am calculating labor share. That is wage into C into D. C is what? Labor, total amount of labor. D is what? D is the wage rate per person, per labor. Okay. So C into D divided by A. A is what? Value added. Right. So this is my labor share. C into D divided by A. Once I know labor share, I can work out capital share. 1 minus labor share is capital share. Right? 1 minus H. That is my capital share. Okay. Now I am coming to the rate of growth in value added. Rate of growth in value added, how do you compute? That is the log of value added, this one minus log of value added, this one, the previous period. Okay. So that will give me the growth rate in value added. Similarly, growth rate in capital, how am I doing? So F3 minus F2. F3 is what? F3 is log of capital. Log of capital in 1 year minus the log of capital in the previous year. So I get that. Similarly, I also calculate the rate of growth in labor. Log of labor in 1 year minus log of labor in the preceding year. Right. Now I am estimating TFPG. So TFPG is what? TFPG is the rate of growth in value added, that is J, minus H3 into L3 minus I3 into K3. Within bracket you write plus, or if you open the bracket it will become minus. So rate of growth in value added minus the weighted rate of growth in capital minus the weighted rate of growth in labor. right? So J3 is rate of growth in value added. H3 into L3 is the weighted rate of growth in labor. I3 into K3 is the weighted rate of growth of capital. Okay. So this gives me the TFPG. So in 1 year it was 1.15%. I have multiplied it by 100. Okay. Then in another year it is minus 10.76, 7.73, like this. You are able to see, right? It's very, very different. Now the question is, I can index it. So suppose first year was 100. So 100 has become 101.15. Then it has become 90.26 because minus 10 point was the decline, then it becomes 97.24. So this is how I am able to get the index of total factor productivity growth, right, for each year. Sorry, index of total factor productivity. This total factor productivity growth is a dynamic concept, total factor productivity is a static concept at a given point in time. I got the index. So now if someone would ask me that what is the average rate of total factor productivity growth in this entire period, then if I am taking an average of this, it is wrong, right? That is what I was trying to tell you. Usually people don't understand and then take the average of the growth rates. Average of the growth rates is a wrong concept. You will have to estimate the index first and then regress the index on T. So log of index. Okay, so this is my index of total factor productivity. You take log of this. Okay, then regress that total factor productivity, log of total factor productivity index on time trend. That will give you the average total factor productivity. Of course, multiplied by 100, that will give you in percentage terms. Is that okay? So this is the summary of your growth accounting technique, where you are able to estimate the total factor productivity growth over each year compared to the preceding year, and then you will also be able to estimate the total factor productivity growth for average total factor productivity growth for the entire period. That is possible from this. Now, no, you can start. log of value added, log of capital, log of labor. These observations pertain to different firms in a given industry. Suppose it is machine tools industry. So I have almost 19 firms. So for each firm, my value added figure, capital figure, and labor is given. So I am assuming technology is given to me. Now, given the technology, which firm is utilizing that technology to what extent? And based on that, I am working out the efficiency. So I will be assuming that there are two types of errors. That one is V, which follows a normal distribution, and then there is U, which follows a one-sided distribution. So what I do, I take the data, to stator. I am following the shortcut, just copy paste. Right? So my data is come in stator. Now I will have to apply that stochastic frontier function framework. So I go to statistics, and then what I do is frontier models. Frontier models would mean that there is a frontier for each level of input with the maximum at another level of output. So it is asking me what is my dependent variable. Log value added is my dependent variable. Log of capital and labor are my independent variables. Okay. And then it is giving me these options: half normal distribution, exponential distribution, and truncated normal distribution. It doesn't have gamma distribution. So these are all positive distributions. So by default, it has chosen half normal distribution. Okay. So I say, okay, this is my frontier estimation. Now I am interested in the technical efficiency index. So that means I am interested in the U values. One is V, another is U. U represents my efficiency or inefficiency. 1 minus efficiency is inefficiency. So I am interested in U values. So here what I will do, I will go to the post estimation menu. Okay. In post estimation menu, I say I need predictions. This is predictions, and their standard is as technical efficiency, etc. Okay. So I say this. Then it's asking me the variable name. So let's say tech F. Tech F is my variable. Minus the log of technical efficiency via this method. Okay. What I will do, I will go to the data editor. See, this column is the technical efficiency. Okay. I am not interested in V because V is a random error. I am interested in U. To what extent one is below the frontier. So first I did the regression, then I went to the post estimation menu. There I clicked on the technical efficiency and I got it asked me for a very new variable's name. I gave tech F, and then it has been mounted in my data editor. Now I will examine within this series which one has the maximum value. Unfortunately, they are most of them are in the same range, right? By and large, very little difference, marginal difference. Anyway, you figure out which one is the maximum. You level it for 100. So suppose, what is it? I think 0.0032898, no, 99. This is the maximum. Okay. So I will say this is my 100. If this is 100, then this will be how much? If this is 100, I can accordingly figure out the other estimates. So the 0.00322879 will become how much? Less than 100, obviously. So I can essentially work out each of the values. Then you will say that how many farms are actually efficient and how much are inefficient, etc. And what is the level of inefficiency. In this exercise, they are almost equally efficient. Okay. So if I say this is 100, then the other one will be slightly below 100. So by and large, they would lie between 90 to 100 or so. But there can be cases where you have efficiency and inefficiency levels can be very different across farms or across industries. So this would serve this purpose of, at a given point in time, given the technology, to what extent each farm or each industry is utilizing the level of technology and is able to experience the efficiency level. Okay. Now this concept has also been, and now so I have shown you the growth accounting technique over in time series data. This is cross-sectional technical efficiency estimation. You can also do the growth accounting technique Anyway, I can mount a T component. T is what I will do, regress, log of value added, log of capital, log of labor, and T. This is pure economic. Okay. What is the coefficient of T? 0.74. So 0.74 into 100. How much it will be? Huge. This shows there is a huge total factor. Anyway, this is a fictitious data set, so it is not the actual data. Otherwise, in reality, it is not possible to have such a high rate of total factor productivity. So this is how you can essentially do. Okay. So this is your pure econometric method. But then this would indicate that on an average over this period, what has been the total factor productivity. You will not be able to estimate it for different years separately, unless you are following the growth accounting. So then, let me do a small thing for you. That is, this application of efficiency analysis in various other areas. So you can apply this technique given the technology or given this maximum attainable level of output or value added. What is the efficiency of each firm or each industry, etc. That you can do for the manufacturing sector, you can also do for the banking sector. Many studies have been done, particularly people with management background have been pursuing this sort of research in the banking sector, that which bank is performing better. And then the next question will be that why this bank is performing better than the other bank. In what way it has a relative advantage. Is it because it is located in the very large metropolitan cities with many number of branches, or it has certain other avenues, certain other advantages? Why so? That is another important line of research. Then people have also used this technique, that stochastic frontier function technique, in the education sector. That you have the potential infrastructure. Now, given this infrastructure, to what extent it is being utilized? Whether we are utilizing the educational infrastructure optimally or suboptimally. Suppose you say you have created a school with very good physical infrastructure, with very good instructors, with very good amenities and all equipment, smart boards, etc. Now the question is whether the performance has accordingly improved or not. You may provide all kinds of facilities, but performance may not improve significantly. Then you would pose the question that why? What is the efficiency, the determinant of the efficiency? Maybe it depends on these amenities, but something more than that. So that is education sector. Similarly in the health sector. So when we say that health infrastructure is poor, so the question is, if we will be able to augment the health infrastructure, will it be utilized optimally? In the rural areas, there is a debate that when you provide certain health infrastructure services, people don't utilize it. Particularly when it comes to gynecological illnesses and other related illnesses. People have certain taboos and women wouldn't like to utilize those services. So then the government would say that it is a wastage of money. Why should we then provide these kind of health infrastructure? You can get into more debatable questions. Suppose there is a very high mortality rate in a country. Could be because accident rates are tremendous, or could be because the infants are dying because they do not have enough maternal and child health care. So now as a government you will have to decide which one you should pursue. Reduce more number of accidents or reduce the infant mortality rate. If you provide more infrastructural facilities for women and child health care and they are not being utilized, then your infant mortality rate will not decline. On the other hand, if you create more roads, widen roads, etc., then your number of accidents may come down and your mortality rate may come down. So you have very difficult policy choices at times and ethical considerations also. You cannot, you can justify by creating more roads, but how would you justify the high infant mortality rate? So there are certain issues. So these sort of exercises will enable you to engage yourself in very interesting policy making exercises. And then once you decide that no, infant mortality rate should get the priority over the road accidents, then the question is, how would you motivate women and children to avail of these services? That the social, cultural practices, etc., all those questions will have to be dealt with. Okay. Then I had also used in my joint work with my supervisor Edwin Mills on population pressure index. That usually people say, the demographers say that see, the large cities have too much of population and therefore the large cities are overcrowded. We said no, that's not true. Large cities are having higher population numbers precisely because they have lot of activities. Therefore, they are able to hold those many number of people in that space. So they have agglomeration benefits. So therefore, more farms are trying to locate here. More individuals are migrating to these spaces. So large cities are not necessarily the ones which are characterized by high population pressure. So we try to estimate the population pressure index. So how did we do this? So we considered that stochastic frontier function framework, and we took population as a function of opportunities, infrastructure, etc. Then we worked out the maximum attainable level of population and the observed population. Then we could see that the observed population is higher than the population which can be held by the infrastructure and the opportunities. Here, the population pressure index is estimated just opposite to the technical efficiency. Technical efficiency is to what extent you are below the frontier. Here, population pressure is above the frontier. That means to what extent your actual population is above the population level, which can be explained in terms of the employment opportunities and the infrastructure. And we worked out the population pressure for each of the cities. Then in the next round, we were posing that what is the nature of these cities? Whether the large cities are characterized by high population pressure index or the cities and towns which are having very low population size. We could see that very small towns located particularly Eastern UP and Bihar, they are the ones which are characterized by high population pressure. That means the population size could be less, but relative to the opportunities and infrastructural facilities, that population is much above than what can be explained by these variables. So it completely refuted the argument of the demographers. We could show that using the stochastic frontier function, we could show that the population pressure index is actually high in the small towns, where the government had to provide a lot of benefits. Similarly, this approach has also been applied in the context of tax collection. The government has created the machinery, has encouraged certain activities, whether the tax revenue which is being collected from a particular region or from a particular state is up to the benchmark in relation to what has been invested. So one can pursue this kind of an exercise and one can work out which state government is optimally much better, more efficient compared to the other state governments. Thank you very much.
Thank you so much, sir, for the incredible, highly knowledgeable, insightful and thought-provoking session. Now I would like to request our Director, Dr. Professor Satyavan Baroda, to felicitate our expert with a memento.
Kami puro photo ini bahas